Okay, so a pod, discover. So we'll see how the services appear in the pod, and those appear as environment variable, environment variable in the pod, in the pod. So, uh, so, um, so how does pod knows about the existing service? So we'll cover that. When service is created first, and pods are created after service. Then when pod is created, so remember you have created the service, and after that you are creating the pod. Kubernetes has an environment variable for each service which exists at that moment. What does mean? If you create a service after the pod, if let's say you created 3 service and then you created a pod, you will have the environment variable for that service, 3 services in the pod, and after pod has been created, you create the 4th service. So this 4th service environment variable will not exist in the pod. So that's how it works. Let's say, so it's the same YAML file which you showed. So what we are going to do is, in that YAML file, you have service and associated pod, and so now then you have another YAML file. So what I will show you is that you create a service and then you create a pod. You will see that service appearing in the pod. And after pod has been created, you create a new service. You will not see that new service appearing in the environment variable inside the pod. So what we'll do is run the random service. Oh, so here I'm running the random service YAML first. This is some random service YAML I've created, and see the environment variable for pod in the first YAML, right? Now check the environment. So okay, so here I'm showing you the other way. So let's go through this YAML files. Name pod same service YAML. So cat name pod same service YAML. So what I am doing here is I am creating a service. First I'm creating a service, and then I'm creating a pod, and of course this is selector name pod and everything. So this pod will have this service. So let's do that. And no, before that, second file random service.yaml. So let's see that random service.yaml. It has some just random service. It doesn't have any pod associated or no selector or anything. It just is a service which has two ports exposing 80 and 443. So now, so first we'll run the random YAML. So remember, this random YAML has no code associated. So we'll see, if this service environment variable are also appearing in the code which we'll create later. So kubectl create -f. So it got created. So now, so if I say kubectl get svc, I will see this service and cluster IP and ports. Now what I'm going to do is I'm going to create this kubectl create -f. So I created this. Now let's see kubectl get port. So why I am not getting this port? kubectl. Oh, I think I might know. Let's see this name port YAML. Control C, VIM, Control V. If I see, this is the latest. I thought image was a problem. It's the same problem. Hyphen I had here. I have all underscore. So let me get the images. kubectl images. I think no. Sorry, Docker images. My mistake. Docker images. And this image is this. I want to see which one has latest. This one has it has 2 versions, latest one and latest. I will just to be doubly sure, I will do this. Then I do the VIM and I change the image to this proper name. Control V. Now come out and kubectl get svc. I delete those both services. No, I need to delete only this service because it will get recreated again. kubectl delete svc name port, then kubectl get port, then kubectl delete port with name port, right? So that gets done. Now where is this one? So create this again. I get the port again. Now it's running. I get the service again. It should be running. Now we'll follow what I have written here. Now what I will do is inside this pod, Java tips SVC name pod, which is this one. Inside this pod, I will run a command and get the environment variables and grep SVC. So let's see this kubectl exec kubectl exec. Let me copy this. Control C, Control V, then env, then grep in caps svc. All right. What did I exec code remove? Named ports. Maybe this is what I have to do. Sorry. What is this? exec port with named ports. Java tips kubectl exec. Oh, this is service. My mistake. What I'm doing, I should get the port with named ports. So this one env. So you will see that random service which I have created, environment variable for those are also appearing here. So here idea is to show you that before you create the pod, whatever services are there before that, it will start appearing in the environment variables of the pod. And if you want to access those services inside your pod, you can use those environment variables. Why do you want to access those services inside your pod? For various reasons, like based upon your, the problem which you are trying to solve. But Kubernetes give you these options. You want to get the, the IP address, the port, it's you see it's creating some environment variable with certain convention, like the service underscore port. This is the service we created an underscore port, and the port number, that port number and things like this. So you can refer those inside your port. Now you can discover the service. So I will just reiterate what is service so that we are on the same page. So you have something created in the port, and let's say you have some application inside the port which is exposing the REST endpoints. Now you want to access those REST endpoints. So you have a service object created outside. Through service object, you can access those REST endpoints, and we have done some exercises for this already in the last session. You can also, so we were using cluster IP, for time being. So we are having service object, we are having port object. Through the labels, we were tying service and port together. And then we were having the cluster IP of the service to access the service, which in turn will invoke the port's REST endpoint. The cluster IP, you can invoke only from within some port in the cluster, right? So that's what we have discussed so far. You can discover the service through DNS also. So now, so Kubernetes has a pod running DNS server, core DNS in kube system namespace, and we'll see that. So first, let's get all the namespaces kubectl has. So kubectl get namespace. So this is the namespace we have, and if you see kube system, so I have changed this. Earlier I was running Minikube. Now I have reinstalled the Docker desktop. So I am not seeing DNS in the Docker desktop. So here default node list public. Oh, these are the namespaces. My mistake. So there's a namespace called a cube system. So now what I will do is I will try to get the ports inside this cube system. So kubectl get ports and hyphen namespace equal to cube system. So these are the ports which are running. And if you see, it has the core DNS also running. Actually, it has two core DNS running. Core DNS, these two ports running for core DNS. So now, so service is the kubectl has kube DNS service. Check below. So if I see, kubectl get service, and in the same namespace, let's do that also. So you have the ports, and then let's check the service in the cube system namespace. So you have kube DNS service also running. So basically, these are the service and the ports which are for DNS, domain naming server, right? So why this service is needed? Because a DNS port might get restarted for new IP. See, here you have the ports in this namespace, and here you are having the service. And we discussed when we started service that why do you need service? Why can't you invoke the ports API directly? We need service because ports, to invoke the ports APIs, we need the IP address of the port. And IP address of the ports can keep getting changed because port can crash and reappear and things like this. So we don't want to rely upon the IP address of the port. That is why we need service. So same in the concept here. Even for the kube DNS, you have the ports, but you access those ports through this service. So now, we discuss this service has same IP always. So Kubernetes configures the kubelets to tell individual containers to use DNS service IP to resolve the DNS names. So this is like normal any DNS thing. So only thing is that in here, the kubelet individual containers will be using the DNS to get the to use the service IP to resolve the DNS name. We will see example of that. How does this work, right? Now all ports are configured to use a Kubernetes DNS server port. We can see the resolve conf file of each container, and any DNS query from ports will be handled by this server. Kubernetes DNS server knows all the services running in the cluster, correct? So the whatever DNS server we are talking about, so this is DNS service which is tying to the DNS ports. So they know all the services which are running in the Kubernetes cluster. So so this is the YAML we'll use. So we'll create some service which we already did, and it has some port which we already have. So these are the ports we are getting, and these are service we're getting. Now what we'll do is we'll go inside inside this port. So let's just follow I will just follow the PPT here. We'll see how this resolution to the service via DNS works. So what I will do is kubectl exec -it. Then okay, I have to get the ports. Kubectl get ports first. So now kubectl exec -it -bash. So we are inside this port now. Now we'll install busybox. While we install busybox, we'll come to that later. You will see why we're installing apt-get update apt install busybox. Install busybox. Okay, installed. Now we'll see the resolve. We'll see here in this slide, we say all ports are configured to use DNS server. Resolve.conf file for each container is modified. So here we are seeing what is that resolve.conf. So let's see that cat etc resolve.conf. See here, you have this so some name server is this, some search, some default SVC cluster, local cluster, cluster.local, and things like this, right? So you have already defined things here. So here, these are the two things we'll focus on. So what we are going to do is so what is a fully qualified name of the service? See here, whatever service we have, we will put default.svc. Cluster.local after that. So let's see the services which we have. Check that here. kubectl will get svc. Okay, so we'll use this. We can use random also. So I have used random in that example. So I will use the same thing here. So what we are going to do is we are going to say busybox. Busybox in help is in ns lookup, and then this. Then after that, default svc cluster local, which was default svc cluster local. So I will do this, correct, and I think that is it. So it's it's pointing to this server. This okay. Let's see what is here. So it's the same. Some server, some address, the name and address. Now what we are going to do is here, if you see the cluster IP, this address of this service, it should be same as a cluster IP in the kubectl get service, and we'll see that. So you see 124, which is appearing as the cluster IP of this, of this service outside also. So idea is that the inside the pod, when some application inside the pod is trying to use some service, the Kubernetes DNS server lookup will get triggered, and that service will get invoked. The IP address of that service get resolved that way. Now, since we are here, let's try to look for the other service also. We have this name port, right? Let's try to see if that also get resolved to this IP address or not. I did not try this earlier. I'm trying this here for the first time, but let's see. Control C. So 10.99.135.19, 10.99.135.19. So the DNS server lookup has resolved to the same IP address as here. Now, so what we have done so far is we have created a service object which is connecting to the endpoint which container inside our port for exposing, correct? But Kubernetes does give you an extra ability to create a service object to connect to the endpoints which are not in Kubernetes cluster, which are outside Kubernetes cluster. So, so which means the service will not be pointing to pod, but to the external IP outside the cluster. So external service can take advantage of below Kubernetes service object features. Now, why would you want to do this? Because you already have a service outside. You have already a REST endpoint outside the Kubernetes cluster. So you could very well invoke it. Why do you want to create a service object inside the Kubernetes and let the request go via the service object and invoke the, invoke the external service from there? Because you might want to Kubernetes, service does provide this load balancing and service discovery features, and we saw service discovery features like, you have this, NS lookup happening, and then you have this environment variables and all those things, and it does provide load balancing features also. So you want to utilize that, then you can create a service object inside Kubernetes pointing to the endpoint outside. Now, one thing we have to remember is services do not talk to pods directly. So once you create a service, internally an endpoint resource gets created, and service points to that endpoint resource, and that endpoint resource points to the pod. So if you want to see the endpoint resource, you can see this. So let's see the endpoint resource of the service. So we have this service. So I will copy this command. Sorry, I can't copy. So kubectl get endpoints, plural, yes, points, and then the service name, this one. So this is the endpoint. This so this is the endpoint, and this is the endpoint. These are endpoints which were created. So service connect to these endpoints. These endpoints connect to the REST API of our application. And so I'm trying to represent this diagrammatically also. So you have a service which connects to endpoint. all IP of matching ports are in this endpoint resource. See here, I have created only one port, for example, kubectl get port. So there is one port, but if we have multiple ports, um, which are matching, the service label, let's say you create a replica set, which are 3 ports, and that the labels of those ports match to the service object, then you will have many ports behind this endpoint resource, because this endpoint resource we did not create, service automatically created that. So this endpoint resource will be catering to all the services. So all IP of matching ports are in the endpoint resource. Service call gets redirected to any one of these endpoints, right? There's no deterministic, any of these ports it can get directed to. So I have not explored it further because, I was trying to search for some external service or something, but I will just walk you through theoretically so that, if you want to try yourself, you can try. Service endpoints can be updated independently. So you can create the service endpoint and you can update that independently. Service can be created without the port selector. So endpoint resource won't. So if you don't have the port selector, so like we have the YAML where we are going to select the label. Port selector is nothing but a label. So your service and your port, and port has a label which service is referring to. So that service will refer to that port. But if you do not have like random services created, there is no port selector. So in that case, endpoint for that particular resource cannot get created, and we can check this out actually. So let's see this endpoint named port, and we have this random service also. Let's see if the endpoint gets created for this or not. There is no endpoint. Why there is no endpoint for this random service? Because if you remember the random service, it is just a service without having any pod or without having any port selector, correct? So and I think I showed you that here, somewhere here, the where did that go? The YAML file for the service. These are random service, and it has only the service. There is no pod here, so that's why there is no endpoint for this. But the other one, named port, it has the service as well as the pod, so that's why the endpoint for this service got created, but for this service we didn't have the port, endpoint did not get created. Okay, so so create service and endpoint separately, so which you can do that. So external service and HTTP and HTTP service. So there's some extra work which you need. So you can create a service, you can create the endpoint separately. Then if you have HTTP and HTTP's external service to connect, there's some extra setup, and you can you can go through the setup. I was planning to go through the setup, and I didn't have time to do this. So if you create ports with the labels, same as the random service, it will start showing as an endpoint, yes, but you try this out as a homework. We'll discuss that in the next point. And I think we discussed in one of the previous session also. So there's an extra work to have this service endpoint connect to the external HTTP endpoint, which I did not do, but the documentation of that work is here. So maybe in future, if I get time, I will do it. But if you want to do it yourself, you can refer this documentation and have it working. Now, if you have an external service outside Kubernetes cluster, and you don't want to remember the IP address or something, you want to create an alias. So very well, you can do that. So instead of service endpoints, we can create an external service by a fully qualified domain name also, right? Ports can connect to service using external service or default, whatever, right? So this is how you create. You have the service object, and then in the spec, you say type is external name. And there you give the external name, like some domain, there's a real domain, like I should be able to connect to this on this port. So now what you do is it hides the actual service and location from this. Now I'm just trying to see. So you have this service, name is external service, spec is type is external name, type is external name, and external name is this, and port is this. So it hides the actual service name and location from consuming port, implemented at DNS level. A simple CNAME DNS record is created for this service. Hence, clients connecting will bypass the service proxy. Yes, a CNAME record points to a fully qualified domain name instead of a numeric IP address. So this is how you can connect to the fully qualified name of the of the actual service. Now,
So we have discussed so far. You create a pod, you create a service, your service has client IP address. You can use client IP from within any pod in the cluster. Client IP cannot be used outside the cluster. Um, the service service information is available via environment variables. You can create a service to connect to external client also. What we have not discussed so far is whatever service we are creating in Kubernetes cluster, within Kubernetes cluster, how to access that service from outside the cluster. Uh, Client IP you can access from within the cluster, but I want to access outside the cluster, Kubernetes cluster. So there are three ways. One is the Nodeport, second is load balancer, and third is Ingress. So this is your Kubernetes cluster. This is service, and these are the ports. So external IP is connecting to service, and then service indirectly internally will route the request to one of these ports, right? So now how to have that happen? So what are these three? Nodeport, load balancer, and Ingress resource. So what Nodeport does is each node on the cluster opens a port on the node itself. So I will read it again. Each node on the cluster opens a port on the node itself. It's not container, it's not pod, it's a node on the cluster. Like cluster consists of some worker nodes, right? So those nodes, and it redirects traffic received on that port to the underlying service. So basically, the external service will be using that port on the node, and once the node receives that request from that port, it will redirect to service, and then service will redirect to some container on some port. So that's how Nodeport works, and we'll see example of that. Load balancer. So it's extension of Nodeport type, makes service accessible via dedicated load balancer. So load balancer redirects traffic to node ports. So, and we'll see example of that. So load balancer redirects traffic to node ports across all nodes. Client connects to service via load balancer IP. So client, so in above node port, client was connecting to port on the node in the load balance, and then that port on the node will directing to send routing the request to service, and the service will route to the some container. In the load balancer, client will know only the client will know the IP address of the load balancer. Client did not know the node port IP. They will know the IP address of the load balancer, and they will invoke the load balancer. Node balancer internally will invoke the node port, and node port then will route to the service, and service will go to the some container on some port. Ingress resource, it exposes multiple services to single IP address. And we'll see the difference between ingress resource and load balancer, but this is one of the important difference. First one, it exposes multiple services through single IP address. Here you have to have one service on one load balancer, and ingress resource reports at the HTTP level. Now trying to represent this in the diagram. So let's say you have this Kubernetes cluster, this boundary, and you have node 1 and you have node 2. There is a port 32333 on both of these node opened, and then you have inside this node you have multiple ports. Here also you can have one or more ports, and this service object which got created. Correct. Now what external client will do is it will connect to the the node ports 3233 address on any of this node or this node, right? And what these nodes will do is when request is received at 32333, this is a node port, correct? This is a node port for this node, this node port for this node. They will route it to the service object. Then service object will route it to the pod or something like 8080 on pod 1 or something. So that's how it works. Now the port range for node port is 30,000 to 32,767. If you give any other port, you will get this error. So I tried to give when I was trying, I give some 33333. So it says not in the valid range. It should be in this valid range. So forward incoming connection to that port, which are part of this service. So this I already explained. So we'll try to do that. So I have this port node port service. Let's see that. So let me come out of it. Cat. What is the name? Port node port service YAML. So what I'm trying to do is trying to create a port, and the label is not port service. This is the same container. So I create this port. Then I will create a node. I could have I have service which is of type node port. So I will create this service also,
and so if you see the it's a name port selector node port service here I'm using, and going back previously, and the label here node port service I'm using. So this is one YAML. So let me do one thing. Let me get this. Let's see kubectl get port. I'll delete those ports and service. Kubectl delete port, so that I have only the ports which I need for that particular topic which I am discussing. Control C, Control V. Kubectl get svc. Kubectl delete svc. Sorry. Okay, so I might not have custom svc created and no code also. So now what I'm going to do is, so this is one, and I just want to know there's a port node port service. This is what I created, and there's a node port service. So I just want to know the XML for this. So grep grep-ir, and I want test-node port where I would have specified node nodeport. Okay, my mistake. So this is node port service symbol. Okay, cat. So this is a service which has same level as this. Let me do this here also. So if you see, it has node service here as label, and this has selector as node service, and this is a type service which has this is service object which of type node port. Right. So now let's create that, and what I will do is I will create the sorry, why I have two times cat. So I will create this node port service first. kubectl create SMS node port service. So one service got created. Now I want to create the what is that? Where is a port? Where is the port? Sorry, port got created. So now I want to create this service. This one. kubectl create -f. So now I got the port and the service. So kubectl get port get created, service got created. Correct. Now if you see, I have given this 32333 in the service. So somewhere I have given this node port. So the service of type node port, then the node port is 32333. Correct. So this you are seeing in the service that it is 32333. Correct. Now, so 323 is a port on the node. The service will be accessible through port 3013 or whatever. So actually 3233 of your cluster nodes. 80 port of the service, and this right, 80 is the port of the service internal IP, and just refer to this example, right? So it goes to 32333, and service is exposed in port 80. It will get route to port 80. Then my container service is exposed on 8080. So it from 323 of the node to 80 of service to 80 of the 8080 of the container. That's how it works, correct? And so this is what I have done. So now what I will do is I will try to so I have this kubectl get ports, kubectl get service. Now what I'm going to do is I will try to, I have not tried this, so I'm trying this for the first time. Let's see if this works. So because I am the node, so local host, sorry, local host colon 32333/tips. So it works.
So because the laptop is a node, and on that node I have export 32333. So I have an access on localhost 323/tips. I will just reiterate for the fourth or fifth time. It goes to 3233 of the port, then that gets rerouted to the service 80 port. Then service will redirect, route it to the 800 of the service, and that 800 of my service is returning this response. So that's how it works. Correct. So this is the last topic which we will spend 2-3 more minutes, and then we'll cover. This will complete the service itself. So now service exposing to the external client using load balancer. So what we discuss is a node port. Now we're discussing the load balancer. So Kubernetes running on clouds usually support auto provision of the load balancer. A load balancer is outside the Kubernetes cluster. Load balancer will have its own public IP address. Load balancer will redirect all connections to your service. Will create a node port on each node. So this is how the flow works. Your external client, this is a load balancer of any cloud, like on AWS or Azure on Google Cloud. So some load balancer will be there. So client will always talk to the load balancer. What this load balancer will do is it will send a request to the node's port, like the node port. Now this node port will send to the service, and this service will send to the individual ports, right? So that's how it works. I do not have any, because I do not have any personal account in any of the AWS or Azure or Google. So I will not show the demo for this, but you can read this article. If you have any you have an account on cloud, less on Google Cloud, you can follow this article and do this. But if you had to, the YAML of this look like this, you have again kind of service. In the previous, we had type as node port. Here we are defining the type as load balancer. Ports 8080 target. I think this is the standard service convention. So if you follow this and you have an account on any cloud, you can try that yourself. So, but remember, the node port and load balancer, these are the two things we covered. So the last one is ingress resource, and this is most important. Now each load balancer service needs its own one IP address, correct? So ingress needs only one IP while providing many services. So this is interesting because each service, so far what we have discussed is, whether it's cluster IP or whether it is other options, each service is supposed to have their own IP address. But ingress resource, they're saying no, ingress resource will have only one IP address, but it can serve many services. Now how? So let's see that I mentioned here. So ingress needs only one IP while providing many services. Host and path determines which service needs to be invoked. For example, /tips, /userinfo, /top10. Each of these service can, this is a context. So this service will be for this path, this service will be for this path, this service will be this path. That's how it works. And this service connected to this port, this service connected to these other ports, and so on. So it operates as the application layer of HTTP network. It provides features like cookie, which other options of the services can't provide, right? If you want to try this out, ingress resource, you have to enable the ingress controller. By default, it is not enabled. So if you are using Docker desktop, you follow this link and you can enable the ingress controller there. There is little more setup which we need to do, which I have not done that. There's some certificate issue I'm running into. So it's taking time I don't have that much time to, figure that out. But if I get to work, then I will, explain you again. So, but let's go through this. So ingress controller needs to run in the cluster, and ingress cluster needs to be enabled for ingress to work. So by default, it is disabled. So because I have Docker desktop, so I followed this instruction. If you have Minikube, then follow the instructions which I have given in this PPT. Ingress controller needs to run in the cluster. We discussed that. It needs to be enabled. Now, different Kubernetes environment provide different ingress controller implementation. Google Cloud provide HTTP load balancing feature of this. AWS use application load balancer, and you can see the example of this. A Kubernetes ingress, AWS ELB ingress controller. Minikube add-on. You can use Nginx as ingress controller for Docker desktop, and this is the instructions you can follow. Right? So, so this sort of covers, the accessing the services outside the from outside the cluster. So what are the things we discussed? Nodeport, load balancer, and ingress controller. Nodeport directly connects to the port on the node, then goes to service and the port. Ingress controller, load balancer, client connects to load balancer, internally it will connect to Nodeport and the service, and then the ports. The ingress controller, basically, yeah. So ingress controller looks like, API gateway. Absolutely, yes. So so ingress controller, you have to enable it, make it work. You can have, ingress controller enabled on your cloud with their own implementation of application load balancer type of things, or you can have Nginx also as as your ingress controller. I have not done it. I have not done that setup. It was a huge setup, so I have not done it. But these are the options. Generally, in your company, there will be a Kubernetes admin. They will be setting this up. So as an application developer, you will be just using it. So, but at least this is how it works internally. What we'll do is, what we'll do now is, where did that go? We'll finish the the last topic, which is readiness probe. What is readiness probe? So pod may not be available to access requests while starting. So pod might be ready, but still loading configs and etc. So readiness probe checks whether pod is ready to accept the connections or not. So how container returns success to the readiness probe is developer's responsibility, right? We have discussed the liveness probe. Liveness probe tells whether your service is live or not. Now we're discussing the readiness probe. Whether, let's say, pod is getting started. Once pod is getting started, you don't want to send the request to the pod till the pod, and it takes some time to start up, right? Pod might not be ready yet. It's starting, it's loading some configuration, connecting to database and things like this is doing. So it's not ready. So till it is ready, you don't want to send the request to the pod. So how do you check whether it is ready? For that, you use the readiness probe. So how container returns sexual readiness probe is developer's responsibility. We'll discuss that. So what are the type of readiness probe? Like in liveness probe, these are types of readiness probe. You can have EXEC, like process is executed. Process exit status code determines the status of the pod, whether it is still getting ready or it is ready. You can have an HTTP GET on your pod, some HTTP GET, which will tell if it is 200, that means your pod is ready. Otherwise, your pod is not yet ready. Or you can have TCP socket probe also. So since it is very similar to liveness probe, please refer liveness sections for how to run. So I have not given I have given example of HTTP GET in the liveness probe. If you go and look back the recording, you will see how to get this HTTP GET to work. But instead of giving that as a liveness, you give this a readiness, and Kubernetes will invoke that to check if pod is ready. Let's say I have used the HTTP GET in your application. If you're using HTTP GET, and Kubernetes will invoke it as a and define that in the readiness probe. So Kubernetes will invoke that. If it is not returning anything or timing out or returning some other response, it will consider your pod is not ready. But if it's returning 200, it will consider pod is ready. So what is the difference between readiness probe and the liveness probe? So if the probe fails, in the readiness probe, no request is sent to this pod. Pod is not killed. A pod will be removed from the service till the time pod becomes healthy. Once the pod is healthy, it will get added to the service again. Okay? So it is just to tell that sometimes pod is starting up, or pod is started up, but some other errors some temporary error has happened in your pod, and it's not ready to accept connections. Maybe it has already, any REST endpoint you expose, there's a number of limit of connection you can accept. One possibility that those connections get exhausted, so it's not ready. So at that time also it will be taken out of service. But once the connections are available in the pod again, it will get added back to the service again. In the liveness probes, if the liveness probe fails, then pod will be killed, and Kubernetes will start a new pod for that. And that's the difference between readiness probe and the liveness probe. You can see more of both services on this link. So I think that's about it.